get started, I would like to introduce KYZEN Zone Eric Bromley.
Thank you, William, and welcome everyone to today's edition of KYZEN's Tech to Tech series. Today we're going to talk about some tips and tricks for your inline washer to help you get the most out of your cleaning process. There's a few little things that we have learned along the way that we think can be helpful. First off, this is just a basic inline wash configuration. On the left side of the screen is the pre-wash, or the entrance end of the system, followed by the wash, the CI or chemical isolation, rinse, final rinse, and dry. There are many different machines available that have some different configurations, but basically this is all the same basic setup. One thing to also keep in mind while we're going through the presentation is that there are 4 variables to always consider for a successful cleaning process: concentration, energy, temperature, and time. You must have 4 of these. You must have these 4 for a successful cleaning. And if you make a change to one of these, it will affect the others. So that's important to optimize your process, as well as the things we're going to speak about. So some of the most common loss factors with inline cleaning machines are evaporative loss through the exhaust systems, the spray manifold alignment and the pressures, plumbing and valve leaks, and just general housekeeping. And also stage separation in the baskets. That would be stage separation referring to the spacing between the PCBs or the baskets as they go through the process. The first and last of these 2 are probably the most common areas of loss. For the exhaust system, typically the exhaust draw or the CFM are set too high. If they are set too high, then as the machine is running and the wash and rinse is being sprayed and atomized, the exhaust quickly draws it up into the overhead and it's gone. So that there's a major loss there. If the dampeners within the exhaust pipes are not set correctly to balance the amount of CFM in one chamber versus the other, this can also cause quite a bit of loss. Excuse me, if there's no way of capturing the mist from the exhaust out of the wash section, that's a great area of loss. You have a system like the KYZEN demister that will allow the mist and the vapor to condense back into droplets, and then it's returned back into the wash tank through a drain line. So it captures quite a bit of not only water, but also chemistry as well, lengthening the bath life and keeping costs down. The design layout of the exhaust piping itself can also be very important. If you notice on the picture here on the right, the exhaust is sloped slightly towards the entrance end or the wash section. There is going to be moisture that gets into the exhaust, and you want that water from the rinses. You're better off to have the water from the rinses flow back into the wash than to have the wash moisture and some chemistry to flow into the rinses, because then it will cause foaming and it can cause poor quality rinsing, and over time it can also deplete the DI beds. So the sloping is an important factor as well. The spray manifolds are also very important. If they're misaligned, it's important that they are facing in the right direction and that the spray pattern themselves is correct on each manifold. It's also a little trick to have the exit end manifold on the top tipped slightly towards the entrance end of the machine. Not a whole lot, maybe the 7 o'clock position, if you can envision that. And what that does is it allows for a squeegee effect where the water itself will blow off or push off any puddling on top of the printed circuit boards, or that may be caught in some heat sinks or components. That will greatly reduce the carryover and the losses. The spray pressures themselves, if they're set too high, then the chemistry is just bouncing off of the printed circuit board and atomizing and being drawn up into the exhaust. We see this quite a bit on the lower spray pressures. If they're too high, that just blast right past the open sections of the printed circuit boards on the belt and blast right up into the exhaust, and then it's gone, or it carries over into the drain or the chemical isolation sections. So you want to prevent that as much as you can. Also, plugged or damaged nozzles. That picture on the right is a good example of a pretty badly plugged nozzle. These can actually cause a lot of misspray or misaligned spray where it'll go all over the place. This is a picture of a nice, clean operating wash section. You see the fan jet sprays and the water jet and the coherent manifolds to the left of that picture as well. This is how it's supposed to look all the time. Plumbing and valves are also a thing to consider. The wash fill valve for the water, if it gets hung open, it may not be a lot that you notice it right away, but as it slowly, continually drops, brings water into the wash tank, it'll not only dilute the wash, but it'll also bring it to the overflow. And in some cases, it can overflow the chemistry and water right out into your drain. So if it's got a piece of lint or something caught in the fill valve, or if you have hard water with a lot of salts or calcium that could cause that kind of an issue, that'll happen. If the drain valve itself is leaking on any of the tanks, but specifically the wash, then that can be an issue. If a small component or even some threads, if they build up into the valve over time, that can cause the valve to hang open. A good way to check on this is follow the drain valve from the wash section down to where it goes to your drain or to your treatment system. And a few feet down from the wash tank, feel the piping itself. And if it feels exceptionally warm, then that's an indicator that your wash is in fact passing by the drain valve and leaking by. So that's a good quick tip to kind of check that area. And the excuse me, the wash tank itself. If you have leaks on the tank or the plumbing or the pumps, if they have a small leak here and there, again, it may not seem like much, but over time and accumulative, they can cause quite a bit of loss. So just regular maintenance kind of things is really important in these areas. Stage separation is also very important. The flexible curtain material that's between the different stages, the wash, the chemiso, the rinse, and even the dry, more so the chemiso and the wash. Those are very important, that if they are torn or worn or if they just become tattered, it's really important to keep those in good condition, replace them if you need to. These will prevent the water and the spray from splashing from one chamber to the next, causing cross-contamination and or going right to drain. So there's a loss there. Many of the inline machines have internal baffles. They have small baffle openings at the back of each one of the chambers where you can fine-tune the exhaust flow. Many times these are left wide open or they're closed altogether. And doing this, it throws off the balance on the machine. So you can have too much exhaust in one area where, back to my first point, it'll actually draw the mist and the moisture right up to the exhaust and it's gone. To a lesser degree, the window and tank gaskets can also sometimes cause an issue. The tank gaskets can fatigue over time through the heat cycles, and they'll start to steam or drip, and you'll lose quite a bit out the back through evaporative loss. The window gaskets, not so much, but they also can get fatigued over time, and they really need to be changed on a regular basis because they'll tend to weep. And if that happens, then the chemistry in the water is just going right to drain and it's gone. So again, the small changes, a small effect can have a big effect overall. This is just a picture of a good separation curtain, the white opaque curtain that's hanging down to the right of the manifolds. Just a good example of how they should look. There's also silicone or different rubbers as well, and their finger curtains are solid. Either one's work fine. The printed circuit boards, the baskets, and the belt itself are another large contributor. This is the easiest one to fix, the quickest one to fix. If the boards are put on the belt too close to each other, then the chemistry will splash off the trailing edge of one board and go right onto the leading edge of the next. And it can transfer through the chemiso sections or through the different sections under the curtains. And it just splashes away and goes to drain and it's gone. We try to tell people to leave about half of the board size spacing in between each board on the belt. That allows the chemistry to flush off the leading or the trailing edge before the leading edge gets to the next spray section. The basket's also being overfilled. This is an example here on the right of a basket that's just overfilled. It's not only is it restrictive on the chemistry's ability to get at some of the components, but it also causes a big big flow channel where the chemistry will flow right off the trailing edge onto the leading edge, or from one chamber to the next. This is a picture, believe it or not, of a basket that has about a half a dozen boards in it already, but you can see through the restrictive nature of the basket itself, plus the way that the boards are loaded, you can't see them that good, but they are loaded corner to corner. Then it's a big via for the chemistry to flow from one chamber to the next and get carried out and lost. This is actually how it's supposed to look. Granted, you could put more into this basket, but if you notice, the basket is wide open, very little mesh material. The boards are spaced out very nicely, so this is how ideally it should be used. And another area along that same line is the conveyor speed. It's always been an issue to get the conveyor speed as fast as possible, but in some cases it can be too fast, where you're not giving the machine ample time to adequately remove the wash from the wash section before it goes into chem isolation. And also the chemical isolation may have some issues. And the dryer as well, not related to really a loss, but if the boards are coming out and they're wet, then it's possible that you have the conveyor speed too high, where the boards don't have adequate time to get blown off and dry in that section. So in conclusion, if you optimize the exhaust setting, confirm the proper manifold alignment, both on the condition of the manifolds, the alignment of the manifolds within the system, and how they are aligned as they impinge the board. Replace any of the damaged curtains. That's very important. It's very easy to do. It can be done right there on the floor. You can get the material through your machine vendors, or you may have a maintenance people that can take care of that for you. Repair or replace any leaking valves. It's just general maintenance. Keep upkeep on the machine. Provide adequate spacing for the printed circuit boards as they traverse down the conveyor belt. Open up the basket surface areas if you can, and if possible, slow the conveyor speed down a little bit. And you do all of these things, and over time, or you'll quickly see the results where they will save you time and ultimately save you money. So that's basically all I have. I want to invite you to please visit our website and check out the Tech to Tech section. I believe we have over 50 different Tech to Tech sessions now available to be viewed. The next topic will be presented on the 30th, and it's How Are You Cleaning Krytox, which will be presented by Joe McChesney, and I invite you to attend that as well. So with that, I'll turn it back to William for any questions, and thank you again.
Thank you, Eric. If you'd like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@kyzen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day. Stay healthy and have a great day.